Well, as I said, everybody, welcome to the March Web LDMS Introductory Training webinar. My name is Claire Hall, and I am the lead LDMS trainer at Frontier Science. This is session number 1 of 2. Both sessions will cover the same information, and both sessions are being recorded. As a reminder, we ask that you stay muted during the call, and please ask any questions you may have using the chat feature in this Google Meet webinar. Today, we are going to be briefly going over what is LDMS, then we will review important resources and contacts, special equipment, and we will do our LDMS walkthrough. Now, who is Frontier Science? We are a nonprofit research organization with over 35 years of clinical trial experience. We act as a trusted data management and statistical center, and we provide software solutions for managing biological specimens. One of those pieces of software is the LDMS platform, or the Laboratory Data Management System, which is a comprehensive LIMS. The LDMS software is fully validated and compliant under 21 CFR Part 11, meets NIST and FSMA guidelines, and follows Frontier Science's software development lifecycle. The primary functions of LDMS are managing specimen inventory, configuring virtual storage, and facilitating data exchange between sending and receiving laboratories. Additionally, data can be exported from the system to Frontier Science, which can then be packaged and sent to other data centers as needed. The diagram on the lower half of the screen walks through how data comes in and out of LDMS. The LDMS workflow is multifaceted. Many clinical trial networks utilize LDMS to help track and manage specimens collected during studies. LDMS was designed for specimen inventory management, allowing you to accession your primary and aliquot specimens. You can create virtual storage that is representative of your physical storage configurations. LDMS can help manage specimen shipping and related documentation by creating the database that will accompany the physical specimens. And LDMS will also allow you to receive aliquot specimens from a sending laboratory. LDMS can also capture certain testing results as well as generate exportable data sets for internal documentation or external use. LDMS is a web-based platform. This means multiple users can perform data entry in the LDMS simultaneously, as long as they have a stable internet connection and access to a web browser. Users can view all data additions and updates as they occur, and data is actively being sent to the cloud data servers at Frontier Science in real time, and there is no need to back up or export your web LDMS database. LDMS is utilized by the sample processing labs, testing labs, and repositories. Labs participating in these clinical trial networks will now have streamlined and standardized specimen data that is collated at Frontier Science into larger network databases. And data packages can then be sent on to statistical centers or other data centers. If Frontier Science is your data management center, then LDMS data is compiled at Frontier in combination with submitted relevant clinical data for respective trials and studies. We will now review some important resources and contacts. First, we have project documentation. If you are participating in any specific clinical trial networks, project-specific guidance will be on our website, ldms.org, under a section called Project Documentation. This is where you will find specific memos, slides, documents, and quick reference guides, which are specific to the project or clinical trial network you are participating in. Next, we have our Frontier Science YouTube channel at FSTRF Films. This is where you will find our previously recorded public-facing webinars that can be viewed at any time. And these webinars can be used for refresher training, for self-training, or training new team members that join your staff. Next is the LDMS training team. They are going to be your resource to schedule training webinars, and you can reach out to the training team at any time. Our contact information is listed here, ldms.training@frontierscience.org. The last resource is LDMS user support. User support is available 24/7 with the exception of a few US holidays. And they are going to help with user account setup and provide new users with their login credentials. LDMS user support is also going to help with diagnosing any problems that you may be running into while utilizing the platform. User support can also troubleshoot label printing as well as barcode scanning. You can contact them via email at ldmshelp@frontierscience.org, via phone, or via the Contact Us utility on the ldms.org website. Next, let's look at some special equipment you may need to utilize depending on the clinical trial network you are participating in. If you are going to be utilizing the barcode scanners in LDMS, you will need a compatible barcode scanner that will be able to extract the global specimen ID from the 2D barcodes that are generated. Additionally, if you are going to be generating labels from the LDMS platform, remember that you need to print those labels on appropriate specimen label stock that must be adhered to each individual specimen. Labels must be printed from an Adobe PDF viewer, such as Adobe Acrobat or Adobe Reader, or the proprietary software that accompanies the label printer. Please do not print the label PDF document out of your browser. We will walk through that in today's training. This next slide is a reminder to any lab managers or administrators on the training today to keep your contacts up to date. You can do that by accessing your Frontier Science portal account. You will navigate to Submit Contact Changes, and here you will select your appropriate lab, and you'll be able to update your team members. Keeping your contacts up to date is very important, especially if there are personal data updates, such as a name or email change, or personnel turnover. As a reminder, LDMS user accounts are created and maintained by LDMS user support to perform the following tasks. You would need to contact an LDMS user support you would need to contact LDMS user support for assistance with creating a new user, managing what features in LDMS a user can access, or resetting a user's password. Of note, users are able to modify their own passwords within LDMS, provided they know their login credentials. To submit account-related requests or other general issues or questions, navigate to the Contact Us page on ldms.org and select Assistance with Login Credentials or using LDMS. Your submission will automatically open a service ticket that will be sent directly to LDMS user support. We are now going to begin our walkthrough of LDMS. We can access LDMS in two different ways. The first is navigating to ldms.org, and here in the upper right-hand corner, you'll see a button that says LDMS Login. The other way is to navigate to webldms.org in your browser of choice. We recommend that you use Mozilla Firefox, Google Chrome, or Microsoft Edge, as these are the three browsers that the Web LDMS platform is validated on. I am now going to use my login credentials to log in. And if you are a new user, you will have received a login ID and a temporary password from LDMS user support. The temporary password will expire after 24 hours. Once your password has expired, you will need to reach back out to user support to receive a new temporary password in order to complete your account activation. Once you have logged in with your login ID and temporary password, you will be brought to this training acknowledgement form. This form confirms that we have participated in some kind of LDMS training and keeps the platform in compliance with 21 CFR Part 11 regulations. Training consists of attending a webinar such as this, reviewing any of the previously recorded public-facing webinars on our YouTube channel, reviewing any of the documents or user manuals on the ldms.org website, or being trained by a fellow team member in your lab. You will need to select Yes, I have been trained, submit your login ID and temporary password once more, and then click Submit. You only need to complete the training acknowledgement form once after you first log in to activate your LDMS account. Now I have one extra step. As a super user, I will be choosing the practice database that we will be using for our LDMS walkthrough. And I'm going to click Sign In. And this will take us to our welcome screen. Now, when you enter LDMS, you are going to be brought to this welcome screen. And I'm going to zoom in and explain some of the features at the top of the screen. In the upper right-hand corner is where you are going to see your user profile information. This will include your full name, your LDMS lab ID, and your time zone. Please make sure this information is correct and aligns with the user who is performing the data entry. To the right of the user profile information is the logout button. And by clicking the drop-down menu, you can change your password. If you need to reach out to LDMS user support, you can click the help button, which will direct you to the Get Help utility at ldms.org. At the end of your session, we ask that you log out completely and you do not allow your browser to save your username and password. This is not only an IT best practice, but as LDMS is recording all transactions that occur within the web platform, we want to make sure that there are no accidental logins by another user, especially in a lab where there may be shared workstations. We want to make sure that the individual who is performing the data entry aligns with the user profile that is logged in. Now, the center navigation pane at the top of the screen will allow you to navigate between the different modules. These modules include specimen management, storage, shipping, reports, labels, test results, data submission, administration, and online resources. Online resources has embedded links to direct you to different resources, LDMS validation resources for your end user validation process, the Frontier Science website, the Frontier Science portal, and the specimen repository websites for those participating in certain clinical trial networks. The first module we are going to walk through today is the administration module, and I'm going to navigate to lab settings. But only certain users will have extended permissions in order to access this feature. The lab settings function, there we go. The lab settings function is going to have a series of features you can turn on and off. These features will be the default settings for your laboratory's LDMS database. The first feature we are going to look at is the checkbox for process tech initials defaulting to current user. When this is turned off, no processing tech initials will be associated with the aliquot or primary specimens. Thus, you will need to manually add those initials to the respective primary and aliquot specimens. When the feature is turned on, the initials of the user who is logged in will be associated with the primary and aliquot specimens created, and this should only be checked if the technician who processed the samples is the same technician that is entering them into the LDMS. I will have this feature turned on for today's training. The next feature we will discuss is the checkbox for require a comment when modifying primaries and aliquots. When this feature is turned off, a comment will not be required if specimen modifications are made. When this feature is turned on, modifications to primary and aliquot specimens will only be saved if a comment is also placed in the comment field. This is a change control process feature which we encourage teams to use. This is a nice feature to use in order to make sure the comments are added when any specimen changes occur. This can include a general post-processing update or resolving a data discrepancy in response to a query. However, we understand it can be a barrier to your workflow efficiency, and we leave it up to the lab's discretion if they choose to use this feature, but I will leave this feature turned on for today's training. Our next module is going to be specimen management. The specimen management module is where specimens can be added to the database. These specimen records can be viewed in an index-like user interface that are organized under their respective unique participant. Participant records are dynamic, allowing users to see all specimen records associated with a study or a visit. The specimen management function will allow users to view our specimen inventory. Again, specimen management is going to be organized by individual participant records, which will have project and participant information at the top left-hand corner of the record, and then showcase all study visits and specimens associated with that participant. To navigate through the different participant records, we can slide to find a participant. We can use the left and right arrows to move one participant record at a time. We can use the first and last arrows to jump from the first to last record. Or we can use the jump to participant function if we know the project and participant ID. You can also utilize the filters on the left-hand side of the screen to narrow down your results. These filters include storage filters, shipment filters, specimen filters, visit filters, enrollment filters, and participant filters. Applying filters will reduce the number of records we are reviewing based on the filtering criteria we have applied. As you can see, when I apply the Frontier project filter, we have reduced our number of records of individual participants. We can see that number has gone down. To remove a filter, select the X next to the filter on each individual filter, or to remove all filters at once, click the Remove All Filters button. Now, the participant record is dynamic, allowing us to see all protocols or studies, visits, and specimens for a specific participant on one screen. The first level of dynamic functionality is going to be the ID2 protocol study field. As you can see, there is a drop-down menu available to me, showing the different protocols this individual is enrolled in. If I select any of the protocols listed from the drop-down menu, we are going to see the visit grid, primary grid, and aliquot grid update, showing us those visit and specimens specific to the protocol. The next level of dynamic functionality is going to be the visit grid. The visit grid is going to show the visit value in units, the collection date, the ID3 or sub-protocol ID, and the clinic value. Now, as I toggle between the visits selected, you will see the primary grid and aliquot grid update showing us those specimens collected specific to the visit selected. Our last level of dynamic functionality is going to be at the primary grid here. If I toggle between the different primaries, we are going to see the aliquot grid update showing us the aliquot specimen specific to the primary selected. I'm going to select week 2, primary specimen number 4. The primary grid and aliquot grid are going to share a lot of features. The first feature is going to be the global specimen ID. The global specimen ID is the unique LDMS identifier that is assigned to all specimens the first time they are logged in any LDMS database. This ID will travel with these specimens even if they are shipped to a different laboratory. The global specimen IDs are going to begin with your LDMS lab ID number, followed by an alphanumeric string, and then end in a 3-digit code. The primary specimen and aliquot specimens are going to be linked by their global specimen ID, and they will share the same parent upstream alphanumeric sequence and be differentiated by the ending 3-digit code. All primary specimens will have a 000 ending, and all aliquot specimens will have a range of 001 through 999, allowing us to have 999 aliquots derived from an initial primary specimen. In this specific example, we have 52 aliquots derived from this one specimen. Our next column in both grids is going to be the status column. The status column is going to show a series of icons that will either be colored in or grayed out. This will indicate to us any flags assigned to the specimens or the physical status of a specimen. When I hover over the different icons, we will get a little text box telling us what the icon means, and we have the following icons. A gray or green circle showing if the specimen is physically available in our lab, a gray or blue freezer icon showing if a specimen has been assigned to the storage module of LDMS, a gray or yellow envelope showing if a specimen has not been shipped, is flagged for shipment, is on a pending shipment, or has been shipped, and a gray or brown clipboard indicating if the specimen has been assigned for testing. The primary grid also has one more icon, a dual figurehead. This icon indicates if that primary specimen has been co-enrolled between studies in order to reduce the collection burden on the participant. Now, the primary grid will have our collection details. This includes our collection time, our primary specimen type, the additive type, the specimen condition code, and the available volume in units. Similarly, the aliquot grid will have the derivative type, the sub-additive or derivative type or reagent information, the specimen condition code, and the available volume and units. So now we are going to ascension into the database, and we can do that by accessing the quick add feature with the specimen management module. Now, before I move on, are there any questions? Let's see if any have popped up in the chat. And while I am checking the chat, I would also like to remind you, if you have not, please put your lab number and your full name of all those attending in the chat so that you can get credit for attendance. You see a few people have put their labs in the chat. There's some AI assistance, but I don't see any questions, so we will go ahead and keep going. So from specimen management, in that drop-down menu, we clicked Quick Add. Once again, Quick Add is going to be where we add specimens to our database. We can add specimens a few different ways, and I'm going to walk through each. Please note that some of the examples that I'm going to show you may or may not be relevant to the clinical trial network you are participating in. So please review your project documentation and follow requirements of the clinical trial network you are a part of. For example, certain clinical trial networks require the use of quick add templates, while others require a manual entry. I will be performing both of these today to demonstrate the different methods within the quick add function. So you're going to see that the quick add screen has data field names that should look familiar. They're the same as the fields that we saw in the participant record. We have the participant information, the enrollment information, the visit information, and then we have our primary and aliquot information going down here. Now, the first method I am going to use to add specimens is going to be performing a quick add entry. So first, we are going to enter our project as Frontier. Then we will add our ID1. So we are going to say today's date, so 28 March 2025A. Then our study or protocol for the enrollment field, we will pick study 1. And I can either type in our study information or I can utilize the drop-down menu depending on how your project is set up. Now I'm going to put in our ID3 information or your sub-protocol ID or record number. We are going to choose ARM A. And I will then choose our clinic value from the drop-down menu. So once again, I can either type or select from the menu. I will then define our collection date. So clicking on this drop-down menu here will populate a calendar. I can click today to populate today's date, choose a date from the calendar, or I can type in our date in the day, month, year configuration. I will just click today. I will then define our visit value and our visit units. This will be our first visit. So to recap, we have defined our participant information, our enrollment details, and our visit details. And next, we need to define our primary and aliquot specimens. So in the primary grid, we are going to click Add New over here on the right. And when I click Add New, LDMS is going to populate our first primary specimen right here. It is automatically going to populate as whole blood or BLD. If I need to, I can change the specimen type by clicking the drop-down menu or typing in the 3-letter code defining our primary specimen type. If I hover over them, I am getting a text bubble indicating the definition of those codes. The 3-letter codes are going to be used to define your visits, visit values, visit units, primaries, additives, conditions, and so on. And you can find a list of all of our 3-letter codes in the back of our user manual. In this example, I'm going to leave the specimen type as whole blood, and I'm going to put in the additive as EDTA. That'll have the 3-letter code of EDT. The condition code is going to remain at satisfactory. And next, I will define our collection time and receive time. And as a reminder, LDMS is in a 24-hour clock. So I'm going to input the collection time as 6 o'clock. And the collection time is the time at which the primary specimen was collected directly from the participant. The receive time is going to be 6:30. And the receive time is the time that the processing lab received that primary specimen. Finally, we will define our primary specimen volume as 10 milliliters. We are going to see the grid down here say aliquots for primary number 1. I will click the Add New button twice in the aliquot grid. And this will allow us to create 2 different aliquot types as a result of the primary specimen we are processing. First, I'm going to define the total number of aliquots, and I'm going to create 3 of each type. The value in this field will indicate to LDMS to create 3 records of each specimen type we are creating. Now I will define the 2 different specimen types. Our first aliquot type is going to be double spun plasma, so the derivative type will be PL2, plasma double spun. Our subadditive or derivative is going to be NA, not applicable. Our condition code is going to be satisfactory. And our volume and units is going to be 1 milliliter. Our second derivative type is going to be PBMC cells. So we're going to put CEL as our 3-letter code, which we can see PBMC cells viable. Our subadditive or derivative is going to be DMSO or DMS, which is the cryopreservation solution. And the condition code is going to remain at satisfactory. The volume will be 3, and the volume unit will be cells, CEL. Built-in LDMS logic will apply a 1 million multiplier to our volume value, allowing us to create PBMC records that are 3 million cells per specimen. So to recap, we clicked the Add New button in our primary information area. We defined our first primary collection as whole blood with EDTA. We defined our collection time, receive time, volume value, and volume units. And then we clicked Add New twice in the aliquot area, and we defined our 2 different aliquot types. As a reminder, these aliquots are the result of processing the primary whole blood. We then defined our 3 double-spun plasmas and 3 PBMC specimens. If this visit had a second or third primary collection, we can add those primary specimens by clicking the Add New button in the primary grid. As you can see, a new specimen populated, and our aliquot grid also refreshed. So we can see this now says aliquots for primary number 2. This allows us to define the aliquots associated with primary number 2. The primary collection is going to be a urine sample with no additive. So our 3-letter code is going to be URN. You can see that's our urine. And our additive type is going to be NON for none. Our condition code will remain at satisfactory, and we will define our collection time as 6 o'clock and our receive time as 6:30. And our volume will be 10, and our volume units will be milliliters. For our aliquots, we are going to only click Add New once. And we are going to update the aliquot total to 3. Since we are making 3 smaller urine aliquots here. In this example, we are not going to be transforming the urine into pellets and liquid, so we are going to keep the urine sample as URN. The subadditive will be NA, not applicable. The condition code will remain at satisfactory, and the volume of the 3 specimens will be 1 milliliter. Now, as I toggle between these 2 primaries, the dynamic functionality should look very similar to our participant records. We are seeing the aliquot grid update, showing us those aliquots related to the primary selected. Once we have put all our participant, enrollment, visit, primary and aliquot information in, I can click the Add button. Once we have put all of our as long as everything has been correctly added to our quick add screen, we will see this successfully added note at the top of the page telling me I successfully added the 3 double spun plasmas, the 3 PBMCs, and the 3 urine aliquots. From here, I will click the the print labels button. This will allow me to generate labels for the set of 9 aliquot specimens we have created. If I have Ascension specimens under a specific project, I may have default label formats predefined for me. In today's example, I'm going to generate an LDMS label that includes a standard 2D barcode. I'm going to change the format to ACTG spec barcode, and I'm going to change the size to 19. And then I will click Generate Labels. This is going to create a PDF document, and as you can see, it automatically downloaded. As a reminder, depending on your browser settings, you will either see your documents automatically download to a specified location of your choice, or you will have a pop-up asking you to open or save the document in a specific location. Please review your browser settings when you are utilizing LDMS to know where your documents will be downloaded to. I have opened our label document, allowing us to view this PDF. So here we have our 2D barcode. Then we have our global specimen ID, our participant ID or protocol and study, our collection date and time, our primary and aliquot details, and lastly, we have our volume and visit details. In order to print these labels, I do not want to print them from the print button in our browser. I want to take this document and open it in the Adobe Acrobat or the proprietary software that came with the label printer. This will make sure I have more robust printer settings, which will allow me to adjust the intensity and burn of printing and make sure that our barcodes are printed at a high enough resolution to successfully be read by a barcode scanner. So once we have printed our labels, we want to verify that they have been printed successfully before we adhere them to our specimens. So we will open a document and we will click in it and scan our barcode label. So let's have our barcodes on the screen, as well as we have a Google Sheet here. So I'm going to click in the Google spreadsheet and I'm going to scan my barcode. There we go. We are going to see the global specimen ID populate in the document, which aligns with the global specimen ID of the label we scanned. This is a note that any labels created prior to the version 11 release on February 23rd, 2025 will still have the FSQ control characters in front of the global specimen ID, which occurs when scanning a barcode outside of the LDMS platform. All labels created after that deploy of version 11 will not have the control characters. As we can see here, we created this today. It does not have the control characters. Verifying our labels have printed successfully will benefit us when we store specimens and perform the QA/QC process in shipping. It will also help prevent any issues downstream with receiving laboratories who may be using barcode scanning to confirm import of your specimens after shipping. I will move these barcodes off the screen. And so now we are going to navigate back to the LDMS platform. Yeah. The next way that we are going to add specimens to our database is going to be by utilizing the Quick Add template. This is going to load information into this Quick Add screen. This will be predefined by our project or our clinical trial network, and I can utilize the template drop-down menu to try to find the template in this very long list, or the template list or excuse me, this template list is going to have all templates that are available across all clinical trial networks. I will utilize our template filters to reduce this template list to find what we are looking for. So I will filter on the project of Frontier, and then I will go to the template dropdown once more. As you can see, I have a shorter list here to choose from, and I will choose our Visit To template. LDMS is going to ask if I want to load the template data. When I click yes, LDMS is going to populate the information here in the quick add screen and clear out any information we may have already started to add. You can see the project's been populated, our study has been populated, and our visit value and units have been populated. And then our primary and aliquots have been populated as well. So here we will see our whole blood with EDTA, and that is going to be our double spun plasma and our PBMC cells. And I can toggle the primary number 2, which here is our urine collection, and it's 3 smaller urine aliquots. So even though this template does most of the work, we still do have some fields we need to fill out. So I will put in our ID1. We will put in that one we created earlier, 28 of March, 2025A. And then we will put in our ID3, which is going to be ARM A. Then I will put in our clinic value, which is going to be 1. And our collection date, which is going to be today. Now, because our primaries and aliquots have been defined, when I click collection date, LDMS is now asking if I'd like to cascade this collection date through to our received date and processing date of our samples. LDMS would like to assume that all these activities happened on the same day. If this information is incorrect and you do not want to cascade that information, I would click no, and then you would be able to manually type in your received date and processing dates. When I click yes, we will see that the collection date and received date were populated with the same date. Lastly, I need to define the collection time and the receive time. So if everything is collected and received at the same time, you can copy and paste within these fields to help reduce your data entry burden. For example, I can add 6 o'clock as the collection time for primary number 1. Then I can highlight this, and on my keyboard, hit Control-C. Then I'll click into the collection time for primary number 2, and on my keyboard, hit Control-V. This will paste in collection time 2. I can repeat this for the received time, make that 6:30. I will highlight that and hit Control-C, and then in the receive time for primary number 2, hit Control-V. Next, I want to review how to use condition codes. In this example, the primary urine sample was not collected, and so the urine aliquots were not created. I'm going to go to our condition code for the primary and set the sample to sample not collected. Oops, hang on. So we're going to find our condition code, and we are going to say SNC sample not collected. I'm going to hit save. And then I will set the condition code of the urine aliquots to SNC. Sample not collected. I'm going to still have a record of these 3 urine samples, but these are going to be 3 unavailable samples that were not created. This method of adjusting the condition code instead of utilizing the delete button to remove the specimens is preferred by clinical trial networks using a template. This allows LDMS and the data management centers to keep a record of the expected collections. In this example, we expected to have 3 urine aliquots, and this will help explain why we do not. I am now going to click the edit button of these aliquots, and this is going to open the edit window. We are going to see the aliquot details. I am going to update the reason the specimen was not collected for this example. I will use the dropdown and I will click Optional Specimen Not Processed. And then I will click Save. This comment will be associated with each of those 3 urine aliquots, and these specimens will all be physically unavailable, but there will be a record of them, which I will show you in a moment. Clinical trial networks will usually have a condition code workflow or flow chart describing the scenarios in which certain condition codes are being used and the appropriate scenarios to use them. Please refer back to your project documentation to make sure that you are utilizing the condition codes appropriately. To recap, I applied a project filter to help me find my templates. I then chose our template from our template drop-down list, and we confirmed that we wanted to load the template data. Then we put in our participant ID, ID3, clinic, collection date, receive date, collection time, and receive time. Therefore, I didn't have to put in as much information as I did with the manual entries example. Now I can click Add, and we'll see that successfully added note that these have been added to the database. Our last way to add specimens to our database using Quick Add is going to be utilizing the Multiple Participant ID feature. First, I'm going to utilize a template in today's example. So we are going to filter by Frontier, and we are going to use the template for visit 3. I'm going to say, yes, I want to utilize this template. So first I'm going to utilize this template, and now I can add a participant. The one we used earlier, so we will use 28 March 2025A. We will add that participant. And now I will have a Google Sheet that has 3 additional participant IDs. These are going to be coming to the clinic today. I'm going to save this as a CSV file. And that is going to the downloads folder. So now, here we go. I will go back and I will upload that file here under the Upload ID1 PID file button. We're going to go to our downloads and select the sheet we just downloaded. I will get a note saying that LDMS has parsed out 3 participant IDs from our file. Here are those 3 IDs listed. I can always modify this list by deleting participants with the delete button and adding individuals back in by manual input. But now we have a list of 4 PIDs, and one we entered manually and 3 we entered by file. A note about the multiple participant IDs. If you are going to be using this feature, we want to remind you to pay attention to your visit information. When you are using the multiple ID feature, you will be creating the same set of specimen records for each individual participant you have listed. This is a great feature to use if you are having multiple participants arrive at the clinic on a specific day for the same visit and same collections. The only information that I would need to leave out is the collection time and receive time, because maybe I don't know when those individuals are arriving at the clinic today. Now I will put the rest of our information in. I will put in our ID3 as ARM A. I'll put our clinic value as 1. And I will put our date as today. And I will say yes when they ask to cascade. And I'm going to leave our collection time and receive time blank because maybe I don't know what time our participants are coming to the clinic today. Again, this is going to be a great tool to use if multiple participants are having the same collections done for the same visit details on the same day. But if multiple participants arrive throughout the day and they are there for different visits and different collections, I would recommend against using the multiple participant ID feature, as you will have to go back and revise your specimen records for each of those individual participants. I'm going to click the Add button. And we are going to see our list of specimens that we have created for the individuals. Now, before we move to post-processing, are there any questions I can answer? Let me check the chat. I don't see any questions in the chat, but just a reminder once again, if you have not already, please put your lab ID number for any participating member at your screen. So your lab ID number and your full name, please, so that we can give you credit for attendance. All right, but it does not seem to be that there are any questions, so we will keep going. I'm going to navigate back to the specimen management function, and we are going to look for the records we added through our different examples today. In order to find our specimens quickly, I'm going to utilize our visit filter, and I'm going to filter on collection date. And I will define our collection date as today's date, and we can see that the number of participant records has greatly reduced down. So our specimen records are going to be reduced to just those records that have collections from today. And here's our first participant that had visits 1, 2, and 3. We can see the collection times are listed. And we then have the 3 participants that we added from the multiple PID entry. And you can see that there's no collection time listed for these participants. We have our 3 participants, as we said, and our first participant that has all 3 visits. So if we navigate to our first participant and click visit 2, and we look at that urine primary, this is the visit where the urine aliquot samples were not created. You can see the status column in the aliquot grid showing that these specimens are not available. That specimen is no longer available. These specimens are not physically available because they were not created, but we do have a record of the expected collection with the condition code SNC assigned to the aliquots. We also have the reasoning why these specimens were not created. If we click the edit button on any of these aliquots, we are going to see that reason given, and we are going to see that SNC for the specimen condition. For our next example, I'm going to navigate to visit 3, and I'm going to look at primary number 1, which is our whole blood sample, or BLD. So we are going to look at our whole blood sample with the double spun plasma. We've added our records to the database, and our next step is going to be performing post-processing on those specimens. We can apply post-processing a few different ways. The first is going to be clicking the edit menu of the primary specimen that does not have a collection time or receive time defined. This is going to open up our specimen details, showing us all of the fields associated with our specimen. Any of the fields that are available here can be modified. So I'm going to update the collection time, receive time, and processing time as they were previously not defined. So our collection time will be 6 o'clock. Our receive time will be 6:30, and our processing time will be 6:45. Now I'm going to click the Save button. And when I click Save, there's going to be a pop-up notifying me that the specimen has been modified and I need to enter a comment in order to for the change to be saved. So I will type in the comment field that I added our collection date, collection time, received time, and processing time. I'm then going to add my initials and today's date. And I'm going to click Save. Now when I click Save, I will get a confirmation telling me our comment has been saved. And I will also see a request asking if I want to cascade the comment through the respective aliquots. I'm going to click Yes. And this comment here is now going to be associated with the primary, but also the associated aliquots. So now if I go to any of these aliquots associated with the whole blood sample and I click the edit button, we can see that the processing time has been added, and so has our comment. So here we see the processing time and we see our comment. If I do post-processing on any of our aliquots, I can go to the edit menu as well. In this example, I'm going to update the tech initials. So we can see the tech initials are listed as CH. We're going to change them to ABC. And then I'm going to add a comment that we updated the tech initials. We'll put the date and my initials, and we will click Save. Now, I will get a pop-up asking me if I want to cascade the changes I made to the aliquot to the other aliquots. I can cascade these comments and change to none of the other aliquots, all of the other aliquots, or only aliquots of the same derivative type. I want to cascade this change to only the double-spun plasma samples, not the PBMC samples. So I will select only aliquots of the same derivative type, and I will click OK. So now if I click Edit on any of these other aliquots for the double-spun plasmas, we will see the tech initials have been updated, and we will see the comment has been added. Now, the other way to update aliquots simultaneously is to multi-select by clicking the Control key and highlighting all the samples you are interested in evaluating. In this case, I will select all of our PBMC cells by holding down the Control button and selecting all of the PBMC cell samples. Now I will click the Edit button. Now you can see the edit window looks a little different as all of the fields are grayed out. However, there are checkboxes next to each field. In this example, I will update the available volume. So I'm going to click the checkbox next to the available volume box, and I will then clear out the value of 5 million and change it to 3 million. Lastly, I will need to add a comment. And then I will click Save. This time, you will notice that I did not have a pop-up asking if I wanted to cascade that information throughout the aliquots because I did a multi-select feature. If I click edit on any of these PBMCs, we will see our updates. So we can see the available volume is 3 million, and our comment is at the bottom. Other features of our participant records are going to be the drop-down menus next to our edit buttons of our aliquot specimens. These will allow you to assign tests to any of the specimens, mark your specimens to ship, or print labels for each individual specimen as well as your primaries. Specifically for the PBMC samples, there is going to be one more option. This is the cryopreservation details, which you can add here. This is additional information around the PBMC samples. In the cryopreservation utility, I can click Results Obtained and then fill out additional data around HIV status, primary specimen details, aliquot details, and technician details. Any changes I make to this screen, I want to click the Save button in order to implement those changes. Now, are there any questions on what we've gone over so far? You can raise a hand and unmute, or you can put it in the chat. Let me check and see. I don't see any questions, but I do see people putting their lab numbers and their names in there, so thank you so much for doing that. If there are no other questions, we are actually going to take a 10-minute break. Here we are. So we're going to take a 10-minute break. We will come back at about 9:10. and we will resume the rest of our presentation. So go ahead, enjoy your 10-minute break, and we will be right back. All right, welcome back. Thank you for returning. I hope you enjoyed your short break. While you were on break, I do see there is a question in the chat that says, why is the collection date in French format? I'm going to assume, are you referring to the 24-hour clock? Is that what you mean by French format? If that is what you mean, if you're referring to the 24-hour clock when you say French format, that cannot be changed. That is needed for international support. So we have to leave the clock in the 24-hour function. Hopefully that answers your question. Oh, the format of day, month, year. That also cannot be changed. That is required for international support. Okay. So we are now going to move on to the storage module. So the storage module can be accessed from the navigation pane at the top of the screen. And we are going to begin with stored samples. Labs can use the storage module to assign specimens to virtual storage locations that reflect the lab's physical storage workflow. The storage tree functionality allows users to visualize how specimens are stored in containers, which can be stored in a rack, on a shelf, in a freezer, and users are able to customize the different storage levels with flexible 2D configurations that represent their physical storage solutions. Here is an example freezer, example 1, -80. So I will start with the freezer. Then I have the shelf in that freezer, and then I have a stainless steel rack on that shelf, and then I have 5 boxes in that rack, and some of these boxes can contain specimens. When we see that plus sign to the left of a container, that means that the tree can be expanded. And you'll also notice a set of brackets next to each sample. Those brackets indicate the individual positions of the sample. So this specimen here is in position A1 in the container, which is in position 5 of our rack, which is in position 1 on our shelf, which is in position 1 in our freezer. So to create new storage, I'm going to go to the Actions drop-down menu, and I'm going to go to Add Storage Unit. This is going to allow me to create a new storage unit, and this is going to be a freezer, refrigerator, liquid nitrogen tank, etc. We will name the freezer 01 freezer, and the type is going to be freezer, and the temperature is going to be -80. But you will see here that I have a list from liquid nitrogen all the way down to room temperature. So we will select -80. And now I'll define our rows and columns. So rows and columns will give us a 2D representation of what our freezer looks like. So we are going to make this have 4x1 sections. Each of those sections is going to have its own shelf configuration that we are going to design next. So if I'm going to be using the same configurations frequently, I can save this as a template by going down here to the bottom and checking off Save as a new template. I would put in a name, and when I clicked Save, it would save that template for me. So now I'm going to click Save, and this will create our 01 freezer at -80. Here we go. Here's our 01 freezer. So our next step is going to be adding the shelf configuration. I will click the drop-down button next to the shelf, and I'm going to click Add New Level. So if I have a template available, I can use that. So I'm going to use the 1x4 shelf template. And this gives us 4 individual positions within the shelf. And I'm going to use this configuration because one of those individual positions will hold a 5x5 stainless steel rack. I'm going to name this shelf 1, and I'm going to click Continue. I will now designate where the shelf configuration is within our 2D structure of the freezer. So here we have our 4 freezer sections, and I can choose any one of them, but I'm going to choose section 1. I'm going to click Save. And now we will see our shelf 1. Our next step is going to be adding the stainless steel rack to our shelf. So from the Edit drop-down menu of shelf 1, I'm going to click Add New Level. Again, I'm going to use a template. I'm going to choose the 5x5 stainless steel rack, meaning I have 25 available positions. I'm going to give this the name of Rack 1, and I'm going to click Continue. I will now choose where the rack resides within the shelf. And here again, we have our 4 positions that our shelf has. I can choose any of the 4, but I'm going to choose position 1. And then I'm going to click Save. As review, I assigned the rack to position 1 of shelf 1 in position 1 of our -80 freezer. Our last step is going to be creating containers that I will assign specimens to. So with our rack selected, I'm going to go to the drop-down menu and I'm going to click Add New Container. I will have one additional feature when adding new containers, and this is adding multiple containers simultaneously as long as they have the same configuration. So I'm going to create 6 boxes, and I'm going to do our template of a 9x9 numeric alphabetic box. And as you can see, we now have a 9x9 box with 81 positions available. Right now, we don't have positions only turned on. This allows me to apply row and column labeling. This box currently has a numeric alphabetic labeling configuration, giving me a coordinate pair system for our 81 individual positions. But if I want to, I can adjust the custom labeling as well as the row labeling, or excuse me, the column labeling as well as the row labeling, using the appropriate nomenclature that best fits the workflow of your lab. I can also turn positions only on, which will give me available 81 individual positions in our box. However, I'm going to have this turned off for this example. The last step I want to do before I click Continue is to review the fill order of our box. The fill order is going to be a set of instructions we give LDMS to automatically assign specimens or containers to the next available position, and we will want the fill order to follow our physical work or workflow. Left to right, top to bottom is pretty standard for a 9x9 cryo box such as this, starting with position A1 and working our way across the top of the box, with our last position being down on I9. However, depending on the specimen type you are storing, you may want to adjust the fill order in order to reflect how you're placing specimens within the container. For example, if you are stacking items on top of one another, say there are dried blood spot cards or test tubes, you may want to do bottom to top or so on. So it's good practice to always review your fill order before you create your containers. I will now click Continue. I will update our box name to be 01 box 1. And I am going to utilize the autofill feature. This will select positions within the box, and it will automatically fill the rack by following the fill order of the rack and placing our 5 boxes in positions 1 through 5 without me having to click continue and confirming each individual position, therefore saving me time and effort. I'll now click continue. I can click the plus sign next to rack 1, and here are our boxes. Let's discuss if I wanted to delete a box. I will need to give a reason for deletion every time I delete anything within LDMS. This is going to be shown on the user event report, which we will review later. I am going to delete box 6 by going to the Edit drop-down menu and clicking Delete. I'll click Delete, and I will need to give my reason for deletion in the text box. So I'm going to say I'm demonstrating deletion. I will put my initials and I will put the day's date. So that is best practice, and I will hit OK. Now we can see we only have 5 boxes now. So now that we've created our storage configuration, I'm going to start assigning specimens to those boxes. I can assign specimens a few different ways, and I'm going to walk through all of them. Some of these ways may or may not be required by your clinical trial network, so please review your project documentation to make sure you're following the requirements of your specific project. For the first box, I'm going to store our plasma samples. So I'm going to click the Edit button of box 1, and I'm going to change our box name. This will now be the plasma box, and I will click Save. To store specimens, our first method is going to be manual storage. So I'm going to go to the drop-down menu of the specific container or box and click Store Specimen. This pulls up the specimen picker window that we saw earlier. So here we are going to see the same set of filters that we saw in specimen management. And for this example, I want to filter on collection date and derivative type. So we'll make the collection date today. And then we will go to specimen filters. We will go to derivative type. And we will filter on the double spun plasmas, or PL2, because I only want to store the double spun plasma samples in this box. Now, when I select those 2 filters, I will have 18 results available. If you look at the ID1 column, you will see that this is across multiple participants. So I have participant A, B, C, and D. For this example, I'm only going to store participant A's sample. So I'm actually going to copy and paste that participant ID, and I'm going to put it into the participant filter. And now we can see that this has reduced down to 9 samples. So now I can either click Select All or click individual boxes on the left. So I'm just going to select the first 3 for this sample example, and I'm going to click Continue. Next, I'm going to utilize the autofill feature and assign these 3 specimens to positions A1 through A3. Then I will click Continue. Now we can see that plus sign next to the plasma box. And when I expand, we will see those 3 samples are assigned within that box. Now, the second way that I can assign specimens to storage is by using our barcode scanner. So for this example, I'm going to store our urine samples in box 2. So we are going to edit box 2 and change the name of the box to urine box. We will click save. Now with our urine box selected, I am going to look in the upper right-hand corner of the window at the plus sign button that I'm seeing here. When I hover my mouse, I am getting a text bubble telling me that I can scan our barcode to store our specimens, or I can move our specimens. If I go up to the rack, shelf, or freezer level, we can see that that plus sign changes to a magnifying glass. Now the pop-up tells me that I can search for a specimen within storage at these higher levels, but I cannot store a specimen at these higher levels, meaning I can only store specimens with the barcode scanner at the container level. So I'll go back to our urine box, and I will confirm that there's a plus sign on this barcode symbol. So now I'm going to scan those specimens, making sure that the cursor is in LDMS. Here we are. So we're going to click within LDMS. There we go. So when I scan our specimen, the select positions window is going to open up, and I will confirm that our specimen is going to go in position A1. Then I will click continue. I will then get a note telling me that the specimen has been stored, and I can do that with our second and third samples as well. This will go into position A2. And this will go into position A3. So again, I used our barcode scanner to assign each of those individual specimens to our urine box. Next, I will demonstrate how to add specimens to a box by using the auto-assign function. So for this example, we will rename box 3 to the PBMC box. So we've got our PBMC box here. I'm going to switch our auto-assign function to on. Excuse me, I'm going to switch our auto-assign function to on at the top of the screen, and then I will select our PBMC box. I am going to store the PBMC samples using the barcode scanner, as well as select specimens function. So I'm going to go to the drop-down menu of the PBMC box, and I'm going to click Store Specimens. First, I'm going to replace the PL2 filter with this derivative filter of CEL for cell. PBMC cells, there we go. And now I'm going to see the available PBMC samples here. So I'm going to select the first 2 PBMC samples. I will click continue. Now, as soon as I click continue, those specimens are going to automatically be stored in the box. And as you can see, we bypassed the selection picker window because those specimens were automatically stored based on the fill order of the box. So now if I repeat the process by using the barcode scanner, you can see that it will automatically populate. So I'm going to pull up the PDMC cells. We are going to click on the box, and I'm going to scan the barcode. So I repeated that process. We got the pop-up telling me the specimen was stored. And now we'll notice that the selection positions window did not populate in either scenario, because when the auto assign is turned on, the next items will automatically be stored to the next available position. This helps with your efficiency and timeliness as long as the fill order allows you this follows your workflow. However, it is going to give you a lack of control. So if you need to move items around to specific locations within a box or create spaces, you may want to turn off the auto assign feature, as you will have more control and flexibility on assigning items. So now that we've stored items, we are going to move our items around. There are a few different ways we can move items. The first is going to be moving individual items. We can do that by selecting the item we are interested in moving and going to the drop-down menu of that item, and then we can click Move that item. I can do this for specimens, for boxes, for racks, and for shelves. So in this example, I'm going to move the first plasma box sample. So I'm going to move this out of position A1, and I'm going to move the specimen into box 4. So we are going to open up our freezer, and I'm going to go to box 4. So we've pulled up our storage tree, and we are navigating to box 4. So if you remember, our auto assign feature is turned off, so I'm manually choosing where the specimen is going to go within the box. Then I will click continue. And now when we expand box 4, we can see that plasma sample is back in box 4. So if we want to move multiple items, I can go to the Actions drop-down menu, and we can go to Move Storage Items. This pulls up our storage tree window, and in this example, I'm going to move all the specimens out of our plasma box and place them into box 4. So here's our plasma box, and I'm going to select the individual plasma samples and click Next at the top of the page. Now I'm going to choose their destination. So I'm going to open that 01 freezer, and I'm going to find box 4. I'm going to select this box, and I will check the autofill feature so that I won't have to select the boxes. And now we can see our plasma box is empty. There's no plus sign, and all 3 of those samples have been moved to box 4. So the last way that I can move items is going to be using our Actions drop-down menu once again, and we are going to say Move Storage Specimens Filter Search. So for now, we're going to remove all filters. This is our specimen picker window. However, we are only going to see those specimens that are already in storage, instead of the store specimens from the edit dropdown where we were seeing all physically available specimens in our database. This is only going to show us the specimens already in storage. For this example, I need to find those plasma specimens and move them out of box 4 and back into the plasma box. And I'm going to do that by utilizing filters. So we are going to filter by participant. We will see the double spun plasmas, PBMCs, and the urines, but I want just the double spun plasmas. So I'm going to filter on our derivative type as well. And here we see those double spun plasmas. So I will select all of those by clicking the check boxes, and that will allow me to move these 3 specimens out of box 4 and back into the plasma box. So once I click continue, I will then get to choose our destination, which will be the plasma box. So we'll select the plasma box. And again, I'm going to use the autofill feature and click continue. And now all of our specimens have been moved out of out of box 4 and into the plasma box. We can see no more plus sign next to box 4. That box is empty, and the plasma samples are back in the plasma box. Now I can also generate some reports from storage. So the first report we are going to generate is at the box level. So I'm going to select our plasma box. I'm going to click the edit button, and I'm going to click the reports drop down. So we open this edit storage container window, and we click the drop down next to the reports button. So first we are going to generate the container report. So the container report is going to be a 2D representation of our box. X's indicate the empty positions, and our filled positions are going to have our specimen details. The legend is listed in the upper right-hand corner of the box. If you are creating your virtual storage ahead of creating your physical storage, you can then use this as a guide to keep those reports alongside your liquid nitrogen tanks to see what you have in storage and how they're organized. The next 2 reports I'm going to generate are at the freezer level. So we go to the edit window and we click that reports drop-down menu. So today we are going to look at the storage detail report as well as the empty storage locations report. So we are first going to generate the storage detail report. The storage detail report is going to be a summary of the specimens in your storage unit at the level you selected. Because I chose the freezer level, we are going to see all of the specimens and how they're organized within the freezer itself. We are going to see each individual box starting from the freezer name all the way down to the box names. And then we are going to see all the individual specimens as well as their individual positions. We'll see that for every box that has specimens in it within the level that is selected. Now we are going to do the empty storage locations report. The empty storage location report is exactly what it sounds like. It is going to show us all available positions within the containers assigned to that level. So for example, we can see for boxes 4 and 5, they are completely empty. So we have 81 positions available, A1 through I9, for those boxes. The PBMC box, the plasma box, and the urine box all have a few slots already filled. So we can see these start at A4. So the last report we are going to generate is the print storage action report from the Actions drop-down menu. So the storage action report is going to be a running log of everything you've created and everything that has moved or has been updated in location within the storage module. You're going to see who performed those actions. So the date range is going to have a start date and an end date of today. I'm going to filter on this date range for today, and for this example, once this loads, here we are. So for this example, we are seeing the actions that we performed during the session. So we are seeing who performed the action and the date that it was performed. This is a helpful report if you have multiple users in the storage module performing transactions simultaneously, because it allows you to see the transactions that occurred by your team members. Now, the next thing that I want to do when I am in storage is I'm going to utilize the mark to ship flags. So I'm going to apply these filters to boxes and specimens within the storage module. Then we can use these filters to find our individual specimens or containers within our shipping module to build our shipment. So first, I'm going to assign our urine box the mark to ship flag. So I'm going to go to the edit drop-down menu and I'm going to select mark to ship. I will select mark to ship as checked off, and I will click save. Now we can see the urine box has that mark to ship flag on it. This mark to ship flag is not mandatory to use in order to assign specimens to a shipment. It is a helpful flag to help you find specimens we need later. So I'm now going to flag our plasma and our PBMC samples in their respective boxes. And so then we will have a box that's flagged as well as specimens that are flagged. So we're going to mark to ship our plasma samples. So we can see that first plasma sample as the mark to ship flag. We'll get our last plasma sample marked to ship. And we will mark some of our PBMC samples as well. Oops, one more PBMC sample. There we go. So now we have our urine boxes marked to ship, and we have individual PBMC and double spun plasma samples that are also marked to ship. Now, before we move on to shipping, are there any questions? I don't see any new questions in the chat. All right, so if there's no questions, we will move on to the shipping module. So we are going to start with shipment history. The shipping module facilitates data exchanges between sending and receiving laboratories by compiling specimen records into a single file that matches the physical specimens being shipped. Labs are able to view their shipment history and generate relevant documentation that may be required to accompany specimens during transit. Data files can be generated for each shipment and sent to the receiving laboratories or repositories. So shipment history is going to show a running log of all completed shipments imported or exported by your database. This includes incoming and outgoing shipments. First, you are going to see your shipment number or index number. That is a unique number to your LDMS lab, meaning your shipment numbers are going to be different from somebody else's. We are going to also see the shipment type. This is whether the shipment was sent or received. The shipment format, meaning the data file format that the data file was associated with that shipment. The destination lab, the sending lab shipment number, the shipment temperature, the setup date, the shipment date, the receive date, and the QA/QC status for all completed shipments. We can click View Shipment by clicking the View button, which will show us our high-level details, such as our general information, our shipment destination, our contact at the sending lab, our shipment notes, and our shipment contents. Now, if we click the View button of the shipping container, we will also see the contents of the shipment itself. For example, how the specimens are organized in their container, and we can see the global specimen ID of the specimens on the shipment as well. So from the View drop-down menu, I can generate any relevant documentation for our shipment, and for received shipments, I can perform QA/QC, confirming that I've received specimens as expected. For any outgoing shipments, I can download the shipping file that I need to send along with the physical shipment to our receiving laboratory. That can be downloaded at any time after shipping is complete. Now we are going to navigate to pending shipments. So to create a new shipment, we'll go to Shipping from the navigation pane and select Pending Shipments. And we will select Add New from the Action drop-down menu and click Create Shipment. In our General tab, we are going to choose our intended ship date, which is going to be today. And we are going to select our data file format. I'm going to leave it as LDMS, but if I was sending specimens to a non-LDMS lab, I would choose a non-LDMS lab file type. As I will define our shipment temperature, I'm going to choose dry ice for this example, and then I will click Save. This is going to give our shipment a batch number and add our shipment to the pending shipments queue. To continue creating our shipment, I'm going to go to the Edit Ship button, and I'm going to click Edit Ship. So I will now look at our shipping destination. So when I choose our destination, I can choose from this address book. And this address book is going to show all LDMS labs indexed by their LDMS lab ID. However, if I am working with a non-LDMS partner and they are not in the address book and I need to add them, I can click the New Lab button and I can enter the shipping destination and enter the associated contact information. And then I would click Save Address, this checked button down here. And then I would click Save and it would add our new address to the address book. So any new addresses saved will be added to the end of the address book, and they will have an index number with the leading 999 in front. And if we choose a non-LDMS lab, we'll see their LDMS lab number here as a locally saved lab ID. So let's select the example lab. So we can see non-LDMS lab ID. If I try to open an LDMS file outside of LDMS, it's going to corrupt the file and then it cannot be opened by the LDMS. So if I'm sending to a non-LDMS lab, I'm going to make sure I change our data file format to a non-LDMS file type. So here we have non-LDMS. We want to change this. Yes, we're getting our pop-up telling us we need a non-LDMS file type. So I am going to select CSV, and we are going to see that warning flag disappear. I am, however, going to select LDMS file format because I'm going to change our shipping destination to an LDMS lab. So I'm going to select the LDMS file. Oh, excuse me. I'm going to select the LDMS lab, and we will see the lab number populate as the LDMS lab ID, and the LIMS type will be defined as LDMS. Now, when we navigate back to the General tab, we see that flag disappear for the data file format. I can then define our contact person at the receiving lab. And I can choose them from that drop-down menu. I can then define our contact at the sending lab. And then we can then define our shipment notes. We are going to say we have no comments. Our disclaimer is that this is dry ice. Our shipment carrier is UPS, and our tracking code is 12345. So as a reminder, LDMS does not communicate with your carriers or couriers. That is the lab's responsibility to coordinate your airway bill and packing label. But you can provide that information here, and it can be kept along electronically with the shipment. Our last step is going to be adding our shipment contents, and I can only do this, or excuse me, I can do this in two different ways. I can add a container from storage, or I can create a new container and cherry pick the specimens that I want on that shipment. So first I'm going to click Add New Storage Container. So we're looking at storage containers, and we're clicking Add New. So we'll click Add New in the storage container level, and this is going to open our storage tree. We are going to expand the freezer we created. And we are going to select that urine box that has that mark to ship flag on. Now, right now we are seeing the entire storage tree, and I can navigate to any box or container I want to add. As I've said, here's our urine box, and it has that green flag indicating it's been flagged for shipping. But if I want to remove some of the clutter I am seeing on the screen and only see those items which have been flagged for shipping, I can navigate to the storage filters menu and set the mark to ship filter for yes. You can see the cascade of our storage tree significantly reduced down to just our flagged box. We are not seeing any of the other boxes that are in storage, and you are just seeing that urine box. That's the only box that's been flagged for shipping. I will select that box and click Add Selected to Shipment. Now we can see the urine box is in our storage container section. Now, if I want to create a shipping container, I can click the Add New button, and that is going to be similar to creating a storage container. So first, we are going to define our rows and columns. So I can click Add New, or excuse me, I am going to create a standard 9x9 cryo box. And we are going to define the specimens on the shipment now. So first, I'm going to choose our primary source order. I am going to choose specimen ID as our sort order, but you'll use the sort order required by your clinical trial network. Next, we are going to click Add Specimens. So this opens our specimen picker window, as we've seen before, and I've cleared out any active filters we had. This is going to show me all specimens physically available in our lab for shipping. So I'm going to use our shipment filter to find the specimens that were flagged earlier. So we are going to utilize the shipment filter of mark to ship being yes. When I do that, I am only going to see those specimens that were flagged for shipping. And as you can see, I have more specimens listed here than just the PBMC samples and the plasma samples we flagged in our last example. So I'm going to look at the ID one, and I'm going to find our ID. Here we are. I'm going to copy that, and I'm going to filter by participant ID. Now we can just see those 3 double-spun plasma samples and those 2 PBMC samples are now the only ones available. So I'm going to select these by checking the boxes, and I will click Continue. And now I have the plasma samples that were marked to ship assigned to our new container. Now I will click Add. And I now have the specimens in our urine box and our plasma and PBMC samples in the new box we created. I'm going to click Save. Our next step is going to be creating the physical shipment, and I can generate some reports to help with that. So I will click the Edit Ship drop-down menu next to our samples, or it's in our shipment, so I can see available reports. First, we are going to generate the manifest. The manifest is going to update in real time as we add or remove data from our shipment. This report can be generated at any time during the shipping process, and it is showing QA/QC is not performed, the shipment has not been shipped yet, the intended shipping destination, the notes, the contact at the sending lab, and I'm also going to see the manifest itself and the plasma samples in the first box and the urine samples in the second box. Next, we are going to generate the container report. Now, the shipping container report, this next report is the shipping container report, and the shipping container report is going to be similar to the storage container report, giving us a 2D map of the specimens on the shipment in their respective boxes. So here we can see the plasma samples and the PBMC samples, as well as the urine samples. Next, we are going to generate the storage report. Now, the shipping storage report is going to give us a line-by-line description of where each specimen is located, from the freezer all the way down to the individual positions in the box. Each specimen will have its own set of information. Once I have our shipment prepared in this example, I can generate our 1D and 2D barcode reports. You can generate these reports throughout the different modules of LDMS, and they'll give a worksheet of barcodes specific to that shipment. The 1D barcode report is going to have a 1D barcodes for your global specimen ID as well as your participant ID, whereas the 2D barcode report is going to have 2D barcodes instead of 1D barcodes. Now that I have our physical shipment set up, our last step is going to be performing QA/QC before we ship. QA/QC is the chain of custody control process. So this process can occur two different ways. We can utilize our pass-fail buttons and manually review the individual specimens with our eyes and confirm or deny that those specimens are the correct specimens that should be on the shipment. Or the other way is to perform QA/QC, and that way the way that is encouraged and recommended and sometimes required by different clinical trial networks is the use of our barcode scanner. So again, this is why we want to make sure that our labels have been printed successfully to be read by our barcode scanner. So if we are performing QA/QC manually, we are going to utilize these pass-fail buttons. With our specimen here, I'm going to remove the physical specimen out of the box and review the details on the label. If the specimen's global specimen ID aligns with the global specimen ID listed here, I'm going to click Pass. And we are going to see an OK. And I'm going to see the scanned ID listed as manual. LDMS is going to use the phrase manual to demonstrate that we did not use the barcode scanner, meaning we only used our eyes to evaluate the specimen details. This is the same with a failed specimen. If I fail a specimen, using the fail button, we are going to get that exclamation mark inside the box. And the scanned ID, again, is going to be listed as manual. However, if I utilize our barcode scanner, our QA/QC window will look a little different. So we are going to look at this specimen. So I'm going to click and make sure my mouse is inside the LDMS box, and I'm going to scan. Here we are going to see that we got an OK inside the box, and the scanned ID shows that the global specimen ID of the scanned sample matches the specimen ID expected. Now, if a specimen is incorrect, we are going to get an exclamation point. So I'm going to see specimen ID under scanned ID if I do this. So this is going to show me if we have the wrong coordinates. So let's select inside the box. If a specimen is incorrect but should be on the shipment and it's in the wrong place, or excuse me, in the wrong position, we will see the correct coordinates populate here in the correct coordinates row. If a specimen is incorrect and it should not be on the shipment at all, we will see the correct coordinates listed as not found, indicating to us that this should not be on the shipment at all. So let's try that. We can see here that the correct coordinates say not found. I will now click Save. And we will see what the QA/QC report looks like. So we'll click QA/QC report. We will generate that report. The QA/QC report is going to capture the same information we saw in the QA/QC window, and we will see if a specimen was scanned with our eyes manually or if the specimens were evaluated with a barcode scanner. We are also going to see the pass, fail, and not performed status. As a reminder, it is the lab's responsibility to resolve any of the failures of the specimens evaluated. Specimens may need to be relabeled because the barcode scanner could not read the label on the specimen that needs to occur. And if specimens are in the wrong positions, they should be placed in the correct positions. If incorrect specimens are on the shipment, they should be removed and placed with the correct specimens. And QA/QC should then be repeated until all failures have been resolved to passes, and we want 100% pass on the specimens evaluated. What that means is you may have different percentages of specimens to evaluate per container, depending on specimen type For example, if you're performing QA/QC on PBMC samples, they need to be maintained in a cold environment in liquid nitrogen as long as possible. And you do not want to break the cold chain. You may be required to only evaluate one specimen per row in the QA/QC process, which would be approximately 10% evaluation of specimens, but that 10% needs to be 100% passing. However, if you have a different specimen type, for example, FFPE blocks, you may be evaluating all 100% of the specimens that are FFPE because at room temperature, they are stable and you are unable to impact the specimen conditions by keeping them at room temperature. And in that case, you may be evaluating 100% of the samples in that scenario. Please review your project documentation provided by your clinical trial network or on your requirements for QA/QC. So now that we've performed QA/QC, I'm going to go back to the Edit Ship dropdown, and I'm going back to the Edit Ship window, and I'm going to make sure that everything is correct. We are going to check our General tab, our Shipping Destination tab, our Contact at the Sending Lab, our Shipment Notes, and our Shipping Contents. And then when I'm sure that everything is correct, I'm going to click Ship instead of Save, and I'm going to click OK. When I click Ship, LDMS is going to create our shipping data file and is going to move our shipment out of pending and into shipment history. You can see that our data file has downloaded here, and we have shipment 252 saved. Our shipment 252 is no longer listed here. And now I will go to our shipment history. And here is our shipment 252. If for some reason I cannot find where our data file downloaded to, I can always go to the View drop-down menu and download the shipping file once again. I am now going to navigate to a different lab database, and we are going to walk through importing a shipment. So we are going to go to Shipment and Receive Shipments. You will see these features: Import as is and Import directly into storage. Selecting Import directly into storage will allow our imported specimens to be placed in the shipping import freezer in the storage module. Excuse me, I meant to click storage. Here we are. Here's our shipping import freezer. So the shipping import freezer is a virtual holding tank similar to the intake freezer in your laboratory. This gives your imported specimens an initial virtual storage location. Then you will move those specimens out of those shipping import freezers into their forever home within your virtual storage configurations. So I will now go back to Receive Shipment, and I will click Select File. We will click that 252 file that was created, and I'm going to click Preview Shipment. I will review the details of our shipment here. And further down, I will be able to view the specimens themselves on the shipment and how they're organized within their containers. I will confirm that our temperature is dry ice, and I will scroll back down to the bottom and click Receive Shipment. Our shipment is now the 360th shipment in the database. So now when we navigate to shipment history, we will see our shipment 360 listed here. I can now perform QA/QC on this received shipment. And I would perform QA/QC in the same way I did with an outgoing shipment by reviewing the specimens on the shipment by using our barcode scanner or by using the pass-fail buttons and confirming that I have received the specimens as expected. I will now go into storage and stored samples and navigate to the shipping import freezer. And I'm going to find shipment 360. From here, I can move our boxes. I can move our boxes or the specimens into their correct storage locations using any of the methods that we have walked through earlier in the storage module, using the Move This Item feature, using our barcode scanner to scan the specimens into the specific locations, or by utilizing the Move Storage Specimens or the Move Storage Items, or excuse me, Move Storage Specimens filter search, or the Move Storage Items option. And next, we are going to move on to the test results module in LDMS, where labs can track assay results on their tested specimens for supported assays. The test results module will allow labs to define their experimental design, including controls, calibrators, and assign samples from their LDMS database for evaluation. Testing results are automatically sent to the DMC, and result reports can be generated for internal records as well as for clinician use. In our most recent Web LDMS update, LDMS for Web now has robust support for pharmacokinetic assays. So the test results module is going to have the test grid here. We are going to see our test results and they are going to be listed and assigned a run ID. You will also see the test name, the run date, the tech initials, and the status. To create a new test run, we are going to click Add New, and we are going to click Add Pending Results. We are going to select the Abbott Real-Time HIV-1 RNA, and that is going to be our test name. We are going to click Continue. I will then select the run date, which will be today. And then our associated tech initials will be added in. Our input volume, we are going to select 0.6 milliliters. And our prep method is going to be M2000SP. I can add a comment if I want. And I will save our progress. This will add the test run to the run grid, which will give me a run ID. I can go and click the Edit button to go back into the test results window, and this time I will navigate to the Results tab. This is where I will have our controls, specimens, and unmatched results grid. Starting in the control grid, we will notice 3 controls listed currently. By clicking the Add Control button here, I can add additional controls by selecting something I have already added to our database or previously used. I will select this and I will click Add. Now we can see that this has been added to our control grid. In the specimens grid, I can add specimens from our database by clicking the Add Specimens button. And these are specimens that you will add to the specimen grid for evaluation. I can utilize the filters here. And I will filter on collection date. And choose some specimens that were accessioned today into the database. Excuse me. We are going to select some double spun plasmas, and we are going to click Continue. As you can see, I've added these 3 specimens to the evaluation, and I have 4 controls. At this point, I'm going to click Save. Now I can go to the Edit drop-down menu for this test, and I can click Pending Test Results Report. This report is going to show us the list of 4 controls and 3 specimens that are going to be evaluated. I can take this report to our bench and perform our analysis, and I even have 2D barcodes for our specific specimens we are evaluating that I could run into our assay equipment. I can also generate 1D and 2D barcode reports, as we've seen in our other modules today, that will give us a list of the specimens on our test run with their 1D or 2D barcodes. Excuse me. So once I've completed our analysis and I have our results file, I'm going to go back into our test run and click Edit dropdown and navigate to the Results tab. And I will scroll to the unmatched. Excuse me. I will scroll down to the unmatched results from file, and I will click Upload File. Doesn't seem the file is here, so we are going to download it quickly. All right, so we are going to click Upload File, and we are going to add our Abbott All sensors. So you'll see I have a confirmation note asking if I would like to add the plate comments as well, and I'm going to click Yes. And you may also have noticed that there was a flash of yellow at the top of the screen. That was the auto matching of the results to the controls. Auto matching occurs when the global specimen ID or other specimen ID align with the sample ID in your evaluation. So in this scenario, our control names aligned with the names of the specimen ID names in our results file, and auto matching occurred. Conversely, the specimen results did not auto match. We can see here we have matches, here we do not. So because they did not align with the IDs in the results file, so the results still are left blank. When this is the case, we can manually drag and drop our results from the unmatched grid in our individual specimen results. If for some reason I drag the wrong result, I can always drag it back down to remove it and place a different result instead. So once I have associated the results to our specimens for evaluation and for our controls, I can click Save. And this will allow me to go to the Pending Test Results view, allowing me to update any results for those specimens. Now when I click Complete, this moves our test results to the completed phase, which allows me to perform the review process. When I open the edit window of the completed test results, you will notice that I now have fields that are grayed out. There are open fields to provide our reviewer details. I also now have a tab for our control results as well as our specimen results. In our specimen results, you will see I have a column. I will have a column for system sensors that were automatically applied based on the limits of the analysis. I can also apply user sensors to any of these specimens. And as I hover over these sensors, we get a text bubble telling us the definition of what that sensor is. These definitions are also listed in our user manual. The control results tab has system sensors applied as well. If I navigate to the general tab, I can also apply a user sensor to the entire run. And then I can add our reviewer details, such as the date, initials, the comments, etc. So we will say test review, and put our date. So this moves our test run into the reviewed status. When we click review, must click the date and put in initials. So then we click review, and this moves our test run into the reviewed status. And you can see that the edit button has been changed to view, meaning I can no longer edit our test run. When I click view, this shows me our run details, and you will notice everything now is grayed out. I am not able to update any piece of information. From the drop-down menu, I can view the history of our run, seeing when I completed the run and seeing when I completed the run and when I reviewed the run. I can also generate the reviewed test run report. This is going to be an internal document giving us a summary of our run, including administrative information at the top, and then the controls and specimens that were evaluated, as well as their results and their sensors applied. I can also generate the participant report. The participant report can be provided to clinicians. It includes information about the participant, enrollment, visit, specimen, and test result. If for whatever reason I need to set my results back to pending because I need to upload a corrected data file, if I go to the Edit drop-down menu and select Reset to Pending, this will require me to define why this is being reset, and this will be captured in the history as well. Although labels can be generated from specimen management, storage, and shipping modules, the labels module is where users can generate labels for a large number of specimens, as long as those specimens exist in the LDMS database. There's also a custom label function where users can create their own label defaults for internal projects. Now, the last module we are going to walk through is the reports module. Labs can utilize the reports module to view standard reports generated from the LDMS database across many categories in LDMS. These queries and their relevant generated reports are standardized, formatted, and maintained by Frontier. Users can download reports as different file types, such as CSV and PDF, for example. Starting in standard reports, we have certain categories of reports that are predefined and pre-formatted. The first report type we are going to look at is an administrative report, and we are going to look at the transaction log report. So I will choose our criteria. In this case, we are going to only look for transactions done today. And I will generate the standard report as a PDF or any flat files listed. So here we have the transaction log report. You will see I performed many transactions today, and this transaction log is going to be your audit trail. This may be requested as part of your end user validations or by audit or regulatory bodies as well. And this transaction log is going to show us who performed the action, the date and time the action occurred, the transaction ID, as well as the actual event that took place. It will also list the transaction type, whether it was an update, a removal, or an addition. Another report we will discuss is the user event report. This is a new report available under the administrative category and shares all events that occurred during the specific filtered criteria. It works as an audit trail. It tracks when the user signs in and signs out, in addition to other items such as the transaction ID range. If more detail is desired on certain events, you can cross-reference this report with the transactional report. So now let's generate this report. If I filter by event date and select today, I will click Generate Report. And we can see all the events that occurred today. The next report we are going to be looking at is a specimen report. So under categories, we are going to choose specimen, and we are going to do the specimen processing report. I'm going to choose our filtering criteria by specimen date, and we are going to select today, and then I will generate the report. So this report is organized by primary specimen and its associated aliquots, similarly to how a participant record is organized, except that this is going to be in page format. We are going to see all our overall specimen details, specimen type, additive, volume, collection, date, received date, collection time, received processing time, and the processing tech initials. We will see that the information for the associated aliquots as well, including frozen date and frozen time. And this is a great report to see if there are any gaps in your data. You will be able to see at a high level if there are any missing fields of information, such as a processing time or a frozen time. Using this report can help you find these gaps that can help you resolve data issues before any queries may be issued by the lab. Now we are going to look at some storage reports, and we are going to do the specimens not in storage report. So this last report, the specimens not in storage report, is going to be filtered on project. And we are going to filter by frontier. And I will generate that report. So this is where all of the specimens that are ascensioned that I ascensioned but may not have stored in storage module of the LDMS. Ideally, we want this report to be blank, meaning that all of our specimens based on our criteria have storage locations in the storage module of LDMS. This report is going to be particularly helpful if you're participating in a clinical trial network that requires the use of the storage module of LDMS. If you generate this report daily or weekly, depending on how quickly you are ascensioning samples into your database, this can help you make sure that you are following through with all of your necessary steps. With this report, you would want to go through and find all of those individual specimens and assign them their respective locations in the storage module. Lastly, the Custom Reports Builder function allows users to create reports using any of the data fields captured by LDMS. Queries are customizable, allowing labs to cherry pick those data fields most relevant to them. Local queries can be saved for reports the labs may need generated regularly, and as mentioned earlier, reports can be exported as different file types, such as a CSV. Now, this concludes our monthly Web LDMS introductory webinar. I'd like to thank you all for attending today's training. If you are interested in learning more about LDMS, we have many training opportunities available, including webinars, video tutorials on our Frontier Science YouTube channel, and additional training materials at our ldms.org website. For project-specific training sessions, we encourage labs to reach out to our LDMS training team. And additionally, if you have any questions about LDMS, please do not hesitate to contact LDMS user support via email, phone, or by using the Contact Us utility on the ldms.org website. Again, please do not hesitate to reach out if you have any questions. We are happy to address any concerns you may have. Lastly, if you have not already, please put your lab ID and your full name of all participating members at your screen in the chat so that you can get credit for your attendance. And if you have any last-minute questions, please feel free to unmute and ask or put them in the chat. But if you have no questions, this concludes the presentation, and I hope you have a wonderful rest of your day. Yes, I see a raised hand. Go ahead. If you have a question, feel free to unmute and ask it, but if not, you can log off the call.